Okay, students, this is the job that the problem that I have already done that in the other video. So this is what the problem given to us, and this is what the optimal sequence we got, and on the way when I do the problem, time over, so I went out. So let me continue about how to do this calculations of elapsed time and ideal time for the given problem. Okay, now the job sequence you have to write as it is. Okay, now M1 M2 are the two machines. In time out time we have to calculate. Ideal time we have to find out separately for machine 1 and machine 2. Now this is what the optimal sequence. Look at that. A F D B C E, A F D B C E. Okay, now afterwards the in time out time of the machine 1 we have to calculate, in time and out time. Usually we are taking 0 as the in time for the machine 1. To find the out time of this, we have to add this time with the time taken by the activity A or the job A by the machine 1. So go back there. Here we see that the time taken by the machine A to do the job A is 1 unit. So this 1 unit we have to add here. We'll get 0 plus 1, it gives you 1. Now this out time becomes the in time for the next activity F. So this out time becomes the in time for the activity F. To find the out time, you go back to the given problem. What is the time taken for the job F under the machine 1? Time taken by the job F under the first machine is how much is given here? 2 units are there. Okay, so we have to add that 2 units. You will get 3 units here. Now this out time becomes the in time for the next activity D. For the next activity D, this out time becomes the in time. To find out the out time, we have to go back to the problem. What's the time taken by the machine B for the activity D? Machine B D. Machine B, sorry, function B, machine A. 4 days it takes. So we'll get what is this function F? 2 days it takes, it will become 3 days, and that 3 unit comes here. Then D we are taking, and machine 1 we are taking there. Machine 1 D, 3 days it takes. So you will get here, add 3 days with this, you will get 6 days. Okay, now this out time becomes the in time for B. Okay, so 6 units comes here, and how much it takes on the B activities on machine 1. B activities on machine 1, it is 4 units. So we have to add 4 units with this, you will get 10 units here. Now this out time becomes the in time for this. Okay, so what's the out time? We have to go to the problem. What is the time taken by the machine M1 to do the C job? M1 to do the C job, that is 6 units there. So add the 6 units, you will get 16 units will come here. Units means here days or months or year, nothing is given, therefore I am taking as a units. So 16 units. This out time becomes the in time for the next activity E. Okay, to find the out time, how much M1 takes to finish the activity E? M1 E, it takes 5 days. So we have to add 5 days with this to get 21 days. So from this what we understand is that under the first machine to do all this job under this particular sequence we get 21 days taken by machine 1 to do all the jobs and that is what. Now let us calculate M2 now. Okay, now to find M2, again in time out time we have to find out. Here this for in time the machine M2, in time for the machine M2 is 1 unit, because here 1 unit is there. After the end of this activity only we can go to the second machine for the activity. Therefore here what is 1 here, that one we have to write here. Now what is the time taken for A under the machine 2? Time taken for A under the machine 2, 3 days it takes. Therefore 1 plus 3 it becomes 4. Okay, now this out time becomes the in time for the next activity. Out time becomes the in time for the next activity. Therefore 4 units comes here. To find the out time we have to find how much F takes on M2. F takes on M2. F takes on M2 5 days. So F takes on M2 5 units. Therefore 4 plus 5 9 units here. Now this out time becomes the in time for this. Now to find the out time we have to go back to the problem. Okay, how much time taken by D under M2. D under M2, here D under M2 is 8 units. 8 units. So let us take 8 units with this, we will get 17 units here. So this out time becomes the in time here. Therefore we get 17 units. Now what B takes under M2? What B takes under M2? What M under B2 is equal to 6. B2 under 2. B2 under 2 it takes some B2 17 days. B2 go there, go back. B, now let me see here, this is B under M2. B under M2. B under M2. B under M2 it takes 6 units. So we have to add 6 units with this. If you add 6 units with this, what you are getting is this 6 units with this, you have to get what? 17. Am I correct? So the 17, then 17 plus 6. 17 plus 6 is 23. 17 plus 6, 23 comes here. Right. So this out time becomes the in time, the 23. Okay. Right. This is what? 23. Right. Now next to C for the machine M2. M2 C, it takes 8 units. So 8 units you take with this, you will get 31. Okay, 31 units. Now this out time becomes the in time for the activity E, you will get 31. So E under the machine 2 it takes 1 units, therefore it will take 1 unit, 32. Now 32 is called the total elapsed time. Total elapsed time, but 21 units itself, the first machine finished. Now up to 32 the first machine is ideal. Up to 32 the first machine is ideal. Therefore 11 hours ideal for the first machine. For the second machine, here it is 1 hour, and here it's and the last one here only 1 hour. So only 1 hour for the ideal time for the second machine. Okay, and this way we can get the answer for the given problem. Thank you very much.